Biosafety cabinet. The introduction, history, HEPA filters, type of biosafety cabinet placement, laboratory hazard and risk management, work practices and procedures. These are the topics which will be discussed. So, start with the introduction. Biological safety cabinets are the primary means of contaminant developed for working safety with infectious microorganisms. So, why biological safety cabinets are built for three types of protection. First one is the protection of the product to avoid the contamination of the work, experiment and the process. Environmental protection from the contaminants within the cabinet. The personal protection from the harmful agents to the cabinet. From the earliest laboratory acquired typhoid infection to the hazardous posed by the bioterrorism, antibiotic resistance bacteria and the rapidly mutating viruses, threats to workers' safety have stimulated the development and refinement of workstations in which infectious microorganisms could be safely handled. So, which is the early prototype, which is used to produce or protect the material. It does not used for the handling of infectious agents. Non-ventilated box, which was earlier designed for the primary containment, which is used for simple operations like weighing. Primary version of the ventilated cabinets, it did not have adequate or controlled directional airflow movement. HEPA filters. So HEPA filter means high efficiency particulate air. So HEPA filters remove the most penetrating particle size of around 0.3 micrometers with an efficacy of at least 99.97%. Removes a broad range of airborne contaminants, fine dust, smoke, bacteria, typical size of around 500 to 0.3 microns, viruses, spores, soot, pollen and radioactive materials. So, the structure. It is a single sheet of borosilicate fiber treated with wet strength paper repellent binder. It is pleated to increase the surface area. Pleats are often divided by corrugated aluminum separators which prevent the collapsing and glued into wooden, metal or plastic frames. You can see how it is made in the picture which is depicted in the right side of the slide. Cabinets, class 1 biosafety cabinet, class 2 biosafety cabinet and class 3. Class 2 is subdivided into type A1, A2, B1 and B2 depending upon the usage. So class 1 biosafety cabinet provides personal and environmental protection but no product protection. A class 1 microbiological biosafety cabinet has an airflow into the cabinet in order to protect the operator only from potential aerosol penetrating in an outward direction from the cabinet. A HEPA filter is filtered immediately above the working area where the particulate is retained as air passes through under a negative pressure. The exhaust air is either returned to the lab in a recirculating mode or exhausted to the atmosphere. To enclose equipment like centrifuges, harvesting equipments or small fermenters. Procedure with potential to generate aerosols like culture aeration or tissue homogenization. Toxic powder weighting. Biosafety cabinets are open fronted safety cabinets. The air is drawn from the room into the working area and then passes through the operator and the product before leaving the cabinet through a HEPA filter, normally ducted to the atmosphere. Next is class 2 biosafety cabinet. Class 2 biosafety cabinet provides personal protection as air is drawn through the front grill into the cabinet. Product protection by the downward flow of HEPA filtered air and minimizing the chance of cross-contamination across the work surface. Environment protection is done by exhaust air which is passed through the HEPA filter. Uses. Work involving microorganisms assigned to biosafety levels 1, 2, 3, 4, microbe-free environment of cell culture propagation, formulation of non-volatile anti-neoplastic and chemotherapeutic drugs, media preparation where a sterile working area is required. Class 2 type 1 biosafety cabinets. Inflow velocity of 75 IFM is minimum. 30% of exhaust and 70% of air is recirculated. Negative pressure plenium is there not to be work for people who are working with volatile toxic chemicals. Typical use is for bacterial, viral, fungal and parasitic procedures. So this is a picture showing our class 2 type A1 bisafety cabinet looks like. Class 2 type A2 bisafety cabinet inflow velocity is 100 IFM minimum, 30% exhaust and 70% recirculation. Negative pressure plenium is present. Typical use is for bacterial, viral, fungal, parasitic and airborne viruses. Minimum use of volatile chemicals and radionuclide if canopy temple exhausted. So what are the precautions that should be taken when you use a class 2 A1 and A2 bisafety cabinets are they should never be hard ducted to building's exhaust system. Fluctuations in air volume and pressure that common are to the building exhaust system sometimes make it difficult to match the airflow requirements of the cabinet. So class 2 type D1 bisafety cabinet, here the inflow velocity is 100 IFM minimum, 70% exhaust and 30% recirculate. BS 1 to 3 usage. Personal and product protection. Minimum amount of volatile toxic chemicals and radionuclides can be used. Must be hard connected to the typical exhaust. Must have interlocking internal blowing with the audible and visual alarm for exhaust failure. Type B2. Inflow velocity is 100 IFM minimum. Total exhaust cabinet has no recirculation. Both biological and chemical vapor contaminants are there. Care with the chemicals should not destroy the filter. High exhaust air volume. Interlock system is required if building exhaust fails. Exhaust fan is needed which precisely matches the cabinet with the airflow volume and static pressure. Must have an interlocked internal blower and audible and visual alarm for exhaust failure. Class 3. A class 3 bisafety cabinet, unlike the class 1 and 2, are fully sealed shell of operative protection. It is a gas tight enclosure with a non-opening view window. Manipulation of product is done by using loud sleeve ports. So this is how a class 3 bisafety cabinet will look like. So you have to note that the chemical tank may be installed which could be located beneath the work surface area of the bisafety cabinet with access from the above. The cabinet exhaust needs to be hard connected to a exhaust system where the fan is generally separate from the exhaust fans of the facility ventilation system. The exhaust air must be double HEPA filtered or HEPA filtered and incinerated. So these are the basic requirements. Selection of a safety cabinet through risk assessment. So you can go through this table. I'll give you 10 seconds. So this table is important for daily work purposes. So I request you all to take care and note down this table. Biosafety level 1. Biosafety level 1, the agents are microorganisms not known to consistently cause disease in healthy adults, and safety equipments are not required except some gloves and lab coat, eye protection, which are recommended. Biosafety level 2, the bacteria viruses that can cause mild disease to humans are worked here. So the class 1 and class 2 biological safety cabinets or equivalent contaminant lab coats, gloves, eye protection are required. In type may cause serious and potentially lethal diseases after inhalation such as Yersinia pestis, Francisella tolerans, Leishmania, pneumonia, mycobacterium tuberculosis, etc. are worked here. Class 1 or class 2 biosafety cabinets or equivalent contaminant lab coats, gloves, eye and face protection are required. BSL 4, the agents that possess high individual risks of aerosol transmission, laboratory infection agents, which cause severe to fatal diseases in humans such as Bolivian and Argentine hemorrhagic fevers are worked here. So confined to class 3 biological safety cabinets, use of a positive pressure personal suit with a segregated air supply is a mandatory.